All right, everyone, please welcome onto the podcast today Mark Madsen. He is the president of Third Nature and a member of the faculty here at TDWI. I'm very excited to have Mark on the show today to discuss real-time data integration and get into the nitty-gritty there. But before we jump into all that, Mark, thank you so much for your time. How are you doing today?
I'm doing great, thanks.
Great. Uh, Mark, you may be aware of this from, previous episodes, but our audience members always like to get to know who I'm talking to. So if you don't mind, I'd love to know before we jump into the actual questions on, real-time data integration. Can you share a little bit about yourself and your background and how you got to where you are today?
Sure. So I started off basically in decision support. So my thing was cognitive science and computers, which got me into a bunch of things and a lot of software development. And actually my really early work was in signal detection and AI. So that's where I was getting my grad degrees. But in reality, there was no AI back, in the 1980s to 90s. So it was really mainly data work, getting data to people to make decisions and getting people to make effective decisions. And so, like, one of my really early real-time projects, which is kind of the topic we're talking about here, was coal mine gas monitoring and
Wow.
trying to figure out, both alerting for safety systems, but also people to make decisions about, do we need to evacuate people and stuff like that.
Wow.
Uh, just kind of a throwback for me. But the transition to data was pretty easy because there's not much happening in AI, and mostly decision-making stuff is the purview of management. So getting, shaping, and making information usable for people and making displays worthwhile and usable for people was the thrust of the rest of the 30 years that I spent doing stuff. And so, yeah, I moved around a lot, developing software, working for vendors. I ran statistics in a company. I managed BI for a few companies. Got tired of doing stuff for other people, did stuff for myself, and that's how I ended up working for all the vendors, helping them design products. So a lot of BI and decision-making interface work for vendors. And here we are today.
Well, that's excellent. And obviously for our listeners, you can see why we have Mark on. He's got a wealth of knowledge and experience in the area here. So I'm excited to get to talk with you about real-time data integration, which is a part of our virtual summit that we have coming up this week. For folks that are interested, I will put a link in the description of this podcast, and you'll be able to, even if you miss the actual live virtual summit, you'll be able to go ahead and register and check out Mark as well as all the other speakers during their talks for this month's virtual summit. But Mark, the title of your course that of the session rather that you're going to be speaking to is First Ask Why: Best Practices in Real-Time Data Integration. But I'm actually going to start with what, because I think that's a great baseline for us. So what exactly is your definition of real-time data? Because I think that's a great place for us to start. There might be a little bit of confusion about what real-time means.
Yeah, I never really liked that word, real time, because it used to mean something a long time ago when people were talking about like machine controls and avionics, and that's what I worked on, was hard real time systems where, and hard real time was this thing that meant like this thing happens and then, exactly 3 milliseconds later this thing happens, and if they happen out of sequence, or if they miss a rendezvous and hand data off to each other, bad stuff happens.
Hmm.
Hydraulics don't work, machines fall apart, airplanes fly out of the sky, that kind of thing. And so
Wow.
that's hard real-time systems where you do a lot of careful analysis, you do things like program proving, and there's actually engineering techniques to design stuff like that. And that's just not the realm of IT and decision making, but that's what real time actually means to like one class of people, but those are all like hardcore engineers. And then there's like what we would call a soft real-time system, with stuff where you're a little bit looser. They still have to happen in very low latencies, but missing by 2 milliseconds. And that's like operating systems and things like that, where yeah, your computer is moving at incredible speeds and it's doing all of these things, but they don't have to follow strict timelines and rendezvous and do all of these things. They sort of just happen, but they have to happen very quickly and sometimes in specific orders. And that's like the soft real-time stuff. And again, that's all embedded in things. When we're dealing with people making decisions and even machine decision making, like recommendation engines on websites and stuff, that's not really even soft real time. That's more like what we would call right time. That was the term somebody coined back in probably like 1992 or something, and they would we need another label for this because it's not that stuff, but it's still important. And really that's where almost everything we deal in lives.
So it's hard, it's soft, and then the right time. It sounds like the right time is the one that's most popular as far as for enterprise use. I'm curious though, I mean, I think when people hear the term real time, they always almost assume that it's that hard real
Yeah.
time that you were talking about. Are you seeing, with processing powers and potentially like the use of AI, generative AI, like a higher need for that hard real time, like millisecond type of data integration?
No, I think if anything, it goes the other way. It's, I mean, the problem there is that when you start talking about the right time stuff, we've been doing that since, well, in my career, 1990. So, ignoring the real time. And that's the stuff where I feel like there's so many words for it, right? There's some people, they talk about streaming and they
Hmm.
mean some form of right time because that's a way of doing it. And there's messaging and then there's right time, which circulated a lot in the BI and data warehousing circles. And there's event-driven architecture is a big thing in the software architecture circles, which is really tied into not necessarily streaming, but thing happens, propagated as fast as possible so that other thing happens, that sort of message transmittal work. And they're all related, but they're tied to different uses and purposes. I think that was kind of the important element is understanding which purposes or things you're trying to deal with. And so yeah, the answer is that yeah, in certain areas there's definitely more use of streaming and so on, but it's not driven or even associated with the AI bits. It's really tied in with uh, what I'd call older stuff, machine learning and various analytic algorithms that get embedded in things. And the rest of it is just task-based work where people have to have up-to-date information to do the thing that's right in front of them. And I think that's important because where a lot of projects seem to go off the rails is we're going to do real time. What do you mean? Well, all of our data is going to be in real time. So anytime you want to look at anything, it'll just be like immediately there, which is practically impossible. I mean, even airplanes don't do this. We dump 2 terabytes of data off of each engine on a plane after it lands into a static system to pull out all of the anomalous events. And, you can't. There's too much information out there. So you have to focus on what's germane to the thing you're trying to do. And,
Hmm.
that's what happens. Yeah.
So I'm assuming, given the three different categories or subcategories, as you've mentioned, hard, soft, and right, organizations, I would assume most organizations have some version of real-time integration technologies that they're using. Can you talk a little bit about what those might be and what their use cases could cover?
Yeah, sure. The irony being that I have a slide, an actual slide. It's an acetate slide. I have this deck from IBM from 1975, and
Amazing.
they talk about instant access to online information. And these used to be called online systems, built on this novel thing that was invented called a database. And you could plug a computer over a network to a database, and then when one person shoved some data into it, another person could look that information up immediately. And that's actually still good enough for probably 80% of the work that needs to be done. And, because it's narrow, it's task-based, and it's focused. It's more when you're trying to get into uh, the realm of machine detection of things, or you're trying to get information from more than one system that it gets hard because you've got, I don't know, orders in one place, and you've got fraud alerts in another place, and you've got customer information in another place. And for somebody to sit down and do something that requires that they go to three systems, that's what led everybody to data warehouses and business intelligence. The problem was those were always loaded nightly, well, or worse. And so you couldn't really stitch all the pieces together. Um, but for that task work, you only needed to stitch tiny bits of data from each system together. And then the question was, well, how do we just get the little bits that we need and put those together? And that's, that was an evolution that really didn't hit its stride until the early 2000s. And most of the analytics work that was done well into like the 2010s was still batch,
Hmm.
batch scoring, batch fraud labeling, batch credit risk labeling, all that kind of stuff. And then um, the banks were largely the pioneers in, trying to do things on like credit cards because you could rack up a lot of charges before it would do detect a fraud, and that drove a lot of things.
Hmm.
And I worked on stock fraud, which is more about, you'd think it needs to be real time because it's about stock trades and block movements of cash and all of this stuff, but it happens across 15 different systems
Right.
and involves usually a ring of people, not one person. And so the complexity of the task requires you to build a model of how parties work together and look for coordinated activity at different points in time. And that's the whole right time argument. It's, well, this happened yesterday, and then this happened today involving these people. And so if I see it within 4 hours to generate an alert based on an analytic model we built on all the history, that's the useful thing. And that model lives out there in a network. And so that model gets this event and that event and that event, and it correlates them and it says, hey, something happened. But the misnomer in real time and streaming work on the tech side, I'd say we can blame the Silicon Valley web application engineer cabal for this, right? All of the LinkedIns and the Ubers and everything is they immediately leap from that to we need to have all this information available on a screen. And then there's just these squiggly lines going along the screen. And every time the line goes way up, somebody immediately responds, which the secret assumption being there's a person sitting there watching a screen, just waiting for the line to move. And that's not at all what this stuff does. You look at that thing after when you get a pager alert or a text or something. And that's where I feel like I think things start to get confused on the projects.
Mm. I guess a follow-up question there. I mean, you just touched on a lot of different use cases. Is there specific kinds of technology that these companies are using when it comes to this real-time data integration?
It it really varies. At the base, because you have these layers of things. First off, you've got applications, and if you have, let's call them classic rather than legacy, because legacy has a bad term, which it shouldn't. But you've got some big corporate back office stuff. Your general ledger and your payable systems and the way your money moves around is really important. SAP and Oracle and IBM sell you this stuff. It's been there for 20 years or more. And yet, that those transactions are happening in quote real time. They're hitting that system, but typically they're not being replicated out of that system at that same frequency. And when you're doing that kind of stuff, which which we've done a lot of, you use data replication technologies. There used to be a lot of these. It's weird. These vendors sort of came and went, and then they came again, and now they're all being consolidated again. But change data capture and data replication were really important because thing happens in database A, the replicator picks it up and transmits it to analytic repository B, where it is now present so that if you come in when you need to, the on-demand side of real time or write time, you see the updated information, but it's doing this across multiple systems coming to one place. So all the different bits are all sort of, as up to date as they can be and as tied as they can be based on the timing. So you can see that stuff. And that we've had that for, well, first time I saw it was probably 30 years ago. So we've had these technologies for a long time. It's just the vendors change. But then there's the newer, and I say newer, and I think back to MQ, which I first touched in 1995. So that's a pretty bad example. But, MQ has been around forever, and it just stood for message queuing. And, there's MQ series from IBM, there's open source MQ stuff. And, then TIBCO and all these other companies, these form the backbones of a lot of transactions and transaction movement. And one of the things they gave you was guaranteed or at least reasonably predictable latency. Like it's going to take exactly 100 milliseconds to get from point A to point B and be available. And, the promise was that 300 milliseconds typically was what data replication could get you. So that's 1/3 of a second, right? So thing happens there, and 1/3 of a second, it's going to be available over here. Those kind of message queuing things said, well, we can actually, instead of writing it to the database, we can send it directly point to point if you really need it, and we could get that time down to 50 milliseconds or less. And so those kinds of things were great for, tens of milliseconds latencies, which starts to help when you have, detectors that need to operate really fast, whether it's, what I consider boring stuff like fraud or sensors. Like I was dealing with sensor data a lot and safety sensor and safety critical stuff.
Mm-hmm.
It's got to be really fast because you're dealing with a whole series of, first the data comes in, then you have to process it and see if it's a thing to pay attention to. So there's a detection interval. Then there's an analysis interval, which for a person is I'm looking at stuff and figuring out what's going on. But for a machine, it's process this and figure out if it's an event that you pay attention to or not. So does it meet the decision criteria? Then once that's done, there's an action piece, which is send a message to make a system do something. Turn off your credit card, step on the brakes, tell a person that they need to do something, that sort of. And then there's the action interval, which happens from that point where, it executes and then situation remedied on the other end. And for those kinds of things, you typically did need messaging. And then the interesting thing is that everybody today does Kafka. Well, everybody in IT does Kafka. Why? Because Twitter made it popular a decade ago. And Kafka is just another message queuing system, but with some unique characteristics that make it work really well at very, very high kind of internet scale. Because like with message queuing, you were limited to like one computer, and the queue depth is just how many messages can I store before I run out of space or can't retrieve them all. And those are big limiters in those systems. And Kafka was designed to run across multiple computers and separate things so that, something crazy happens, like in a, power outage and a whole lot of stuff. All of a sudden, there's this wave of activity. You can overwhelm systems. And so to avoid overwhelming systems, you separate receiving messages from consuming messages. And that way, when a whole lot of stuff comes in, the consumer could tell the producer, whoa, back off. But with Kafka, you don't need to because it just persists these things in a big distributed mess of storage. And then the producers can catch up and you can absorb these waves of incoming stuff and you can scale up the consumption side to consume stuff coming out the other side. And so a lot of e-commerce infrastructure and other things got built on that, but that is much slower. It's much lower latency than TIBCO or MQ. Or, now there are these things that you use in website operations. in web operations and also in monitoring analytics systems like recommenders that you might run on websites
Hmm.
of transactions. Those use things like Prometheus, which is super low latency. It's really designed to be instrumented into applications and operating systems and provide bits and pieces of messages, and all of that stuff comes together very, very fast at very low latency. And those are the things you use when you need truly really low latency, millisecond type timings. And there are definitely use cases. Most of us in most corporations have a very narrow place where we need that stuff. And mostly, our business doesn't depend on the app being up. Like if you're Lyft or Uber, if the app is broken somewhere, your business isn't operating. And
Right.
so you need that kind of stuff, but what you generate is logs and alerts. And the alert tells there's an outage, there's an incident. Then you come together with all the right time data that's persisted as history to figure out why is this happening, what's going wrong, how do we get this back? And that's what a site reliability engineer uses. So that's at the very very low tolerance end of the spectrum versus Kafka queues and yeah, whenever I get it, Twitter type stuff at yeah, it's real time, but it's actually not.
Well, that was so fascinating taking me through all of that. Thank you for that. I'm curious though, based on the need and on some level within every organization to have some, right time data, what are the top, things to consider for organizations that want to implement real-time data integration? Like what can go wrong there?
Yeah. I don't do as much IT advisory work as I used to because I ask questions that people don't like. And the first one is usually, why are you doing this? Because I try not to say it like with that disdain, but why are you doing this? Because a lot of times the idea is, it's a noble idea. We're going to make decisions faster. And that's usually the impetus behind things. And it's built on this idea of if only we had known sooner, which, is kind of a variation on the whole, you only live once. Gosh, what were we thinking? But the challenge there is that whole process of detect, analyze, decide, act that has to happen. And a lot of times people did have the information. They just didn't act on it because the reaction time of the process and the decision making itself are the problem, not the fact that the data isn't real time. And if you can get somebody to explain that,
Hmm.
then the rest follows. And so when you're looking at, what kinds of uses and how do I figure this out? You have to move from this sort of abstract hand wavy, we need real-time data to, okay, what for? What, why do you need this? Well, so we can make decisions faster. Okay, who's making the decisions? Is it like operational task people in a call center, or is it business managers managing inventories in a warehouse, which have very different timing needs and decision, latency. Like here, people are going to hang up on you if you make them wait for 2 minutes while you look something up, unless it's really, really important to them. Or, on the other end, it's like the warehouse manager is 15 minutes late to a meeting, and then he's got to come out of that meeting late, and then 2 hours later, he finally gets around to this thing that he got an alert on.
Right.
That's a very different sort of and so that's what leads you into, do I need just some database replication that's going to copy some data? Do I need a real-time data mart that collects up a bunch of different things so that when something happens, like an incident, I can respond to it? Or do I need like some retailers, not many, but some do real-time out of stock alerting,
Right.
where in the store, they actually get messages saying that, inventory is here, sales are here, there's only three things left on the shelf. You should probably go check that shelf for restocking. And sometimes it's right. Sometimes it's wrong, because maybe somebody just restocked the shelf and the system doesn't know it because, you got these little scanners to like scan
Hmm.
the barcodes on the shelf and doing that sort of operation is very in the moment. And that's where you understand the task, but that task only needs shelf inventory, demand levels from the cash register, the point of sale system, or if this is online, it would be your order entry system and your inventory management system, and nothing else, right? So you need narrow bits of data, and so why are you doing this? Going from the abstract because it'll be better to, these decisions. Okay, these decisions need this information and this latency, which then guides you to, what technology. And maybe a different way to answer your question too would be to guide you to buckets of system, right? Because there's like real-time data collection. A lot of developers just mean that. And there's a good reason. Like, I'm not saying that this is bad. Um, they got a bunch of weblogs or event trackers or application data or something, and it's not going into a database. It's being pushed into a message queue somewhere, like, it's Kafka queue, and it's just flowing over the network. And if you don't write them down, you lose them. And so and this is true of a lot of SaaS applications, like cloud applications. You can't use change data capture because you don't own the database. The cloud vendor owns the database, and you have no access to it. So your only mechanism is APIs that typically just emit a message or you call them. And so you need to collect the data and just persist it.
Hmm.
You may only process it once a day as part of ETL for a data warehouse, or process it into an analytic data set via pipeline once an hour. But real-time collection is the sort of class, and you're just doing it to collect the data. You don't know what you're doing with it, or you're going to lose it if you don't record it. And like an incident response where I mentioned there's an outage, what caused it? We don't know. So you just go to the real-time collection system that's got all the different bits of data, and you sift through that to find the things that are relevant to you, and you do that analysis. Collection's good enough. Everything else can happen after the fact.
Hmm.
Versus real-time integration, which is I need a bunch of things correlated, and I'm tracking metrics, which are calculated based on three different discrete data values. To do that, I actually have to take the data in real time, process it, and store the output. And so real-time integration is what we did with active data warehousing and operational BI and so on. And that's still consumption happens later, but all of the data is there. And then there's real-time analysis where you actually get it onto the screen. And then there's real-time analytics where you have to push the calculation into the network. And then, that gives you a separate set of things. So you can look at a decision and say, does it have to happen here, 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 or here? And then you know which bucket you're in, and then you can decide what to build. And that's kind of how I, work through the quick triage of systems when I'm asked to.
Yeah, that's so interesting, and I'm not shocked to hear that why is where you think people should start. I think that goes for a lot of. I mean, in data and analytics, the whole industry, it feels like you really need the why before you should start just throwing money and time at it. And then also the
Yeah,
process part.
that's
I mean, it's such a fascinating journey that you took me through that whole process of decision making. But I think that goes for a lot of different cases in business. Period, not just in this particular example.
yeah, you're absolutely right. I mean, honestly, when I was an IT manager, the why question was the thing that always made me unpopular because I would ask earnestly, why do you want to do this? And there's this giant gap between why they want to do it, which is the good thing,
Sure.
and the outcome. Like, why do you want to do this? Well, we, profit. And then big question mark. And then on the other end of it is technology we want to buy. And usually it's the reverse. It's some IT person wants to buy stuff because it's the cool new thing. Like you mentioned AI at the beginning, and nothing could be further from real time than AI because like yeah, I've seen the actual farms that you use to train foundation models.
Hmm.
And you know, when we're processing the data for a foundation model, we've got 20 billion text fragments in little files scattered over this petascale storage grid. And then we've got hundreds or more server racks full of servers, and each one is processing snippets of this stuff. And periodically they have to come together and flesh this out. And it takes weeks of 24 by 7 processing to construct the model. And then when you use the model, you know, that has to happen much faster because
Hmm.
that's the, you know, the inferencing piece. But typically, what is happening with like especially language models, a person is interacting with the system, and human latencies are, you know, several orders of magnitude slower than machine latencies. And so most of the time there's nothing really there. It's just part of application infrastructure. You know, you don't need it for that.
Hmm.
Now, if you were trying to do real-time image detection, which, you know, you could consider deep learning for that, an AI model, it's just a, you know, it's an image classifier that's saying this, maybe to do real-time threat detection or safety detection, because there are things where you use camera systems for safety purposes. And, you know, those need to get the data, process it, and then turn around really quickly what you know, the classifier needs to say, yeah, there's a bad thing about to happen here, or a bad thing did happen here. And so you look for that. And those are again very narrow, very specific,
Hmm.
targeted purposes. And you don't need to, you know, do everything. You only need this one narrow application to do it. So yeah, that's
It's fascinating.
why is always at the root.
Yeah, that's right.
Yeah.
Yeah, that's so true. And it really is fascinating though, like the different facets that are touched by the real time, near time, right time data integration stuff, and th those that we might not even consider
Yeah.
that are actually most impacted by by this. And maybe
Yeah.
not the dashboard that you use every day so much as you know all the other stuff going on in the background.
Yeah.
Um, well, Mark, it was an absolute pleasure talking with you today. I think we're going to end it here. But before we go, I want to ask if there's a good place for people to reach out to you if they listen to this or they see your talk on our virtual summit this month. Is there a good place for them to reach out and connect with you to follow up with a question or, you know, maybe inquire about your services?
Yeah, sure. People can always hit me up on LinkedIn. Messaging is open. Uh, that's probably the best place. I mean, I have a website, hasn't been updated in 7 years, but
That's all right.
such is life, right?
That's right. Busier things to do.
Yeah,
Uh,
exactly.
well, again, folks, Mark will be speaking at our virtual summit. First, Ask Why Best Practices in Real-Time Data Integration is the title of his session. I will put a link in the description of this podcast for folks that are interested in tuning into the entire virtual summit. It's a 2-day summit. Of course, you'll be able to see Mark there as well. But Mark, it was an absolute pleasure talking with you today. I really appreciate your time. You have a good rest of your day, okay?
Thank you.
To subscribe to the Speaking of Data podcast, or to learn more about TDWI's research and training on all things data management and analytics, visit tdwi.org or click the link in the description below. Thanks for tuning in.